Students, welcome to ZimSIC Robotics Lab. With me, the Zim Science General. This is a series of videos where we cover combined science syllabus topics from Form 1 to Form 4. So watch this video to understand the following topic better. Symbol machines today. A symbol machine is a device which makes work easier. Types of symbol machines include levers, pulleys, gears, inclined planes. We also have wedges, a wheel and an axle as machines, but we are not going to cover them in this topic. Levers. Examples of levers include a pair of scissors. A pair of scissors is got where you put your fingers, which is the effort side. Then we have where the scissors moves is the pivot, and the cloth or paper or whatever is being cut represents the load. We have a wheelbarrow as a lever, where you handle the wheelbarrow, pushing it represents the effort, and this is the load. And finally, the pivot. Crowbar is a second example of a lever. A crowbar, we have the load, which is represented by L. We have a pivot and an effort where you press to lift up the load. We discussed the crowbar in the previous video. The distance of the load to the pivot is 0.8 meters. Then the distance from the pivot to the effort is x. Machines involve the following calculations, which can be based on the crowbar above. Mechanical advantage, abbreviated as MA, is equal to load divided by effort. In this example, our load is 50. 50, how do we get 50? 5 times 10 to get 50. Then 20 newtons, then MA is 2.5. Velocity ratio, abbreviated as VR, is calculated by dividing the distance moved by effort, dividing it by distance moved by load. In our example, distance moved by effort is 90 centimeters, and we convert that into meters to get 0.9. We deal with SI units, and the SI unit of distance is a meter. We don't deal with centimeters when you are doing calculations in physics. Then 30 centimeters, when you press down here, the load will move upwards to 30 centimeters. So 30 centimeters, 0.3, if you divide this, you will get 3. Take notice that MA and VR have no units, since the units cancel out each other. Efficiency is simply mechanical advantage divided by VR. Then since it is a percentage, we multiply by 100. In our example, MA is 2.5, VR is 3 times 100, and the answer you get is 83.3%. I have left the percentage here, which you should not do so. Then the distance x in the diagram above, we use the formula involving the principle of moments, where clockwise moments at equilibrium balance anti-clockwise moments. We calculate moments as force times distance, force times distance. Then our force is 20 newtons, the clockwise moments, and the distance is x. Then 5 kg becomes 50. Then we divide, then the distance is 0.8 meters. When we do our calculations, x becomes 2 meters. Then the second type of symbol machines include pulleys. or simply the pulley system. We have a simple fixed pulley system where the pulley is fixed to something above it. Then the load will be lifted by pulling the effort downwards. Then the single pulley system, single moving pulley system, it is the string that is attached to the top. Then the pulley and the loader at the ground. Then a person who is operating the pulley which is moving will be at a raised position so that he is able to pull both the load and the pulley upwards. Then VR for a single pulley system is automatically 2. Mechanical advantage, we have 60 newtons if you look on the diagram, then 40 newtons, we get 1,5. No units as usual. Then effort becomes, not effort, but efficiency. Efficiency becomes 1,5 times 100 divided by 2. Remember the formula, Ma over VR times 100, and you get 75% efficiency. We go to a 2-pulley system. A 2-pulley system has got 2 pulleys. One which I have shown in red, which is the moving pulley one. Then the one which is in blue is fixed. So in a 2-pulley system, one is fixed and one is moving. Ma is load over effort. Our load is 90, which is 9 kg times 10. Then our effort is 50. We divide 90 by 50, we get 1,8. Then VR is 2. We simply count the number of pulleys. So VR is 2. Efficiency, Ma divided by VR times 100. Remember we got Ma as 1,8. Then VR 2 times 100. Then our machine, while it's 90% efficiency, this percentage is not clear, it's percentage. Then the third type is a 3-pulley system. A 3-pulley system has got 3 pulleys. Look, the blue ones are fixed, while the one which moves with the load is in red color. Ma is load over effort, 90 times 40. 40 effort, 90, which is 9 kgs times 10. We get 2,5. VR is 3. How do you get VR of pulleys? You obtain the VR by counting the number of pulleys. Then efficiency, like before, VR, Ma, which is 2,5, VR 3 times 100, and the efficiency is 75%. The fourth type of pulleys has got 4 pulleys, a 4-pulley system. A 4-pulley system, look, the fixed ones are above in blue, and those which move, the free moving ones with the load, are in red. Then Ma, like before, load over effort, 90. 9 kgs times 10, 90. 90 divided by 30. 30, which is the effort, is 3. VR is 4. Again, how did you obtain it? By counting the number of pulleys. 1, 2, 3, 4. Then efficiency, Ma over VR. Ma is 3. VR is 4 times 100. 75. Look closely at how the strings are put through the grooved wheel. If the number is even, 2 above and 2 below, the string starts from the top, look, going through the groove of the first red ones, then goes to the blue, down here to the red ones, and finally from the big red one to the bigger or a big blue one. Then machines are always not 100% efficient. including pulleys, all machines inclusive of pulleys. Then what causes a pulley not to be 100% efficient? Some energy is lost as heat through friction, which means some energy is used to overcome friction is wasted away by overcoming friction. Then the second way by which a pulley is not efficient is that some energy is also wasted in lifting these moving pulleys. Remember, these moving pulleys, they have got weight, which is also passed on to the load. So some energy is lost through moving pulleys, raising pulleys upwards. Then how do we increase the efficiency of pulleys? By lubricating the axle. It is the axle that is lubricated. A mere answer of just lubrication will not earn a mark. Using light moving pulleys, that is, those pulleys in the red color in the diagrams above, they should be lighter than the ones that are fixed because they are lifted together with the load. Type of machines are gears. The velocity ratio of gears is very simple to calculate. You simply say velocity ratio is called to number of teeth on load gear. The bigger one is the load, divided by number of teeth on the effort gear. The smaller one is the effort gear. Then VR for this example becomes number of teeth. I've labeled them for you for easy counting, 1 up to 8. If you count them, you get to 8. So bigger gear, load gear, has got 8 teeth. The smaller one has got 4 teeth. So if you divide VR as 2, so gears are simple to work with. Then the fourth type of machines are inclined planes. The velocity ratio of an inclined plane is distance moved by effort. Remember, the effort, your aim is to raise the load up to a height of 4 meters, but you can't do it straight away. You have got to use a slant, an incline to go up 4 meters. So the incline, the length of the incline represents the effort. Then VR therefore becomes L over H. L, which is 6, H, which is 4, then you get 1,5. Then like before, Ma is load over effort. Your load is 40. 4 kgs times 10 to get 40. Then effort you are given is 30. Then efficiency becomes Ma over VR times 100, 1,33 times 100 over 1,5 times 8. You get 88.7%. This machine, I failed to find where to write how to increase the efficiency of this machine. You increase the efficiency of this machine by polishing the inclined plane so that it becomes smooth, reducing friction. Then another way is to use this inclined plane, this plane, you put a plane with rollers so that the load will easily roll over until it gets to the height, the intended height. Thank you. See you in the next video. Thank you for watching this video. Please like, follow, and subscribe to our Facebook page and YouTube channel.